Welcome everybody to this is I guess a special edition of a Presidio Bitcoin podcast because we're talking about a report that recently came out. And Ashu, you played a huge role in this. Why don't you take the lead and tell us a little bit about why we're here?
Yeah, sure. Well, I think the best place to start is probably a quick round of introductions. So, uh, people who consume Presidio Bitcoin media are probably familiar with the person who's farthest to our right here, Steve Lee. But Austin and I have not spent as much time on this side of the studio, on this side of the table. So, I'll start. My name is Ashu. I work here at Presidio Bitcoin, doing a lot of our content stuff. I'm often behind the producer table, not back here. And I also, I guess, kind of led the charge on this quantum report, our Bitcoin's quantum readiness report, but with help from a lot of other people as well. Besides for that, I guess background, I have a few years under my belt as a research analyst, so I think that also definitely helped me out here.
Hi, my name is Austin. I'm usually never in this environment over here, kind of in the corner working. I have a Spiral grant working on programming lightning.com. Go to that website if you want to learn about how Lightning works from the ground up through coding exercises. And then last year, I helped lead the Presidio Bitcoin Quantum Summit. And I'm sure we're going to talk about that today. Played a big part, I think, in helping us get to where we are. And I think that's why I'm here sitting in the chair.
Yeah, I'm Steve Lee. Typically do the PBJ podcast. These two guys did the lion's share of work on this report, but I've been reviewing the report. I'm super excited for it. I think it's the most, neutral, comprehensive, unbiased report that's been produced. None, as far as I know, none of us are like investors in quantum computing companies. I'm sure we're all long Bitcoin, but we just care what's most about we care most about Bitcoin's future, and and dealing with the questions around quantum. So I think that's primarily what we hope to get out of this report. We also, it's not just a report. I think importantly, we launched it as a project because what we've learned putting this together is that every week there's new information coming out that impacts what's being done, what's the state of readiness. And so we launched it as a project which accepts contributions from anyone. It's an open project. So we welcome the audience to hopefully read the report, learn from it. If you spot errors or any way to improve it, we are very open and welcoming to improvements to this.
And do you want to maybe tell us a little bit about your day job? Because I do think it's somewhat relevant here.
Sure. My relationship to Presidio Bitcoin, I helped found it a year and a half ago. I also lead Spiral, which is a block initiative around open source Bitcoin. We have the luxury of choosing whatever projects we want to work on in the Bitcoin space, which primarily is around software development and open source software development. But we also work on advocacy and just dealing with some of the thorniest problems in the Bitcoin space. And the current, often discussed topic is quantum Bitcoin. So is it a problem? How big a problem is it for Bitcoin, et cetera? I guess the exposure, mitigations, and upgrade paths is the subtitle of our report. That's what we're going to focus on.
Yeah, yeah. All right, great. So talking about being the founder of Presidio Bitcoin, I think that so to Presidio Bitcoin's involvement with quantum goes back quite a ways before I even started here last June. So maybe you can tell us a little bit about what brought quantum onto your radar a year and a half ago. What made this interesting to you? Why you thought Presidio Bitcoin was is worth covering it here and doing something here. And yeah, maybe just give us some background because I think it really became loud and in front of us in the discussion, maybe starting November, December. But PB has been thinking about this for a year and a half or more at this point.
Yeah, I mean the topic of quantum and how it could impact Bitcoin has been something that I've been aware of and heard of for a decade now in Bitcoin, and it predates my involvement in Bitcoin. So that's not new. I do think like 10 years ago, it was common for Bitcoin developers and Bitcoiners in general to dismiss it, and that quantum computers aren't real. They're never going to come about. There's still a lot of questions around that topic, and we can talk about it a little bit on this episode. But I think what caused us to take action with the Presidio Bitcoin Quantum Summit last summer was that uh, there were investors and developers that I have had long term relationships with and know really well and respect really well, who were approaching me saying like, "Hey, there have been quite a few developments, both on the potential threat side, but also developments on the cryptography side, like to deal with the issue." Um, that coincided with a desire by Presidio Bitcoin to host like a R&D type of event, and more the R than the D, like research, like a technical research topic. And then we landed on, instead of doing an event that covered 12 different topics and issues, we're like, let's take one of them head on and go deep on it. And so we decided to do the summit. And I mean, I can describe it, but I'll let Austin describe who came to that event, what were the topics, what did it cover?
Yeah, so the Quantum Summit honestly was very, very similar to the report that we just put out, largely in structure as well. So we began the summit by talking about the state of quantum computing. We had some people come who work at quantum computing companies, CTOs, like well known people. You can go see the list of speakers on the website or go look at the um, recordings of the talks. I probably won't out specific groups of people that came, but broadly, the representation was investors, certainly. Cryptographers came both within the Bitcoin space and a little bit outside of the Bitcoin space. A lot of Bitcoin developers came. And again, there was the folks that were on the quantum computing side. So it was well rounded from that perspective, certainly. And we started with the state of quantum computing, then focused on what the impact would be to Bitcoin, which we'll talk more about today. And then we went into what are the various proposals, focusing on day one, mostly on the ones that have to do with like Bitcoin's base chain. And then day two, we did a little bit of sidechain and rollups, etc. I do want to briefly review, like all good events, we had a survey go out the first day and the next day. So we have a little bit of a gauge on what was the impact, at least on people's opinions of things. So I will read off the first, there was only 3 questions, like all good surveys, few questions. So some takeaways. Before the summit, 25% of respondents were unsure if cryptographically relevant quantum computers, CRQCs, would pose a significant risk to Bitcoin. After the summit, this dropped to 8%. That was one takeaway. Another takeaway, preference for burning quantum vulnerable coins decreased by 7%. So before the summit, there was at least a stated preference that was higher for burning, and then that actually moved closer towards doing nothing, as opposed to something perhaps in the middle like Hourglass. And then third, uncertainty about Bitcoin's post-quantum security approach fell from 33% before the summit to 10% after. I think that is also something we're very much trying to convey with this report, is that people, especially back then when it was like early 2025, mid 2025, it was kind of like, what is Bitcoin doing? Like, are people like Bitcoin, quote unquote? But what are people working on? What are the developments? What is the status? So the summit was largely getting everyone together to talk about that. And then now this report is kind of a follow up and trying to lay out again, what are people doing? What is the state? Where are we going?
Yeah. So, and yeah, that summit was a huge success. It was an awesome event. So thank you so much for leading it, Austin. And then I guess that dovetails into our second output, second quantum output, which is this report. Um, I guess just to set some context now for this report, we can talk a little bit about sort of what was the goal of the report, the purpose, and what's the scope of it. So I can start because this was something that I'd been working on for a while beforehand, and then we really kicked into gear this year, and it did take us some time to put it together. But I think one of the things was having something that was both comprehensive and concise. Um, because I think that there are, like Chain Code has a fabulous report, but it's about 50, 60 pages, which can be hard for a lot of people to get through. And then there are other things, right? Like some people write articles on Twitter, and those are great, but those are more informal and much shorter and might not cover everything. So I think, our report, which is about 12, 13 pages, does a good job of kind of hitting that middle ground where it's something that, you can read through in, you know, 15, 20, 30 minutes. But also you kind of get a full idea of what's going on in all different facets of uh, the crossover of Bitcoin and quantum computing.
There's also like a one page, the eight key takeaways are on one page. So that's, you can think of that as like an executive summary as well. Because we do hope that this is a go-to shareable piece of content for people. So whether it's a Wall Street investor or just a layperson in Bitcoin who read some headline in the news about the quantum problem with Bitcoin, or Bitcoin's going to die, or they just have questions, this we hope that this report is what people reach for to share with people with these questions.
Yeah, yeah, totally. And then I think one of the coolest parts of this report, and it was actually like almost last minute that we decided to do this, is the fact that it's uh, open source and that it's a living paper or a living document. So since Steve, you've done something like this before with the BCAP project, maybe you want to tell us about some of the thinking behind that and why that's so valuable, especially for this topic.
Yeah, a project a couple of years ago that Lynn Alden and Crypto Ren and myself worked on, the Bitcoin consensus analysis project. We launched it as a living document, and open source project, because while we did the creation of this document, there's no, it's not like we get to decide how Bitcoin consensus is analyzed or what the right framework is. So we're just like, here's a good starting point for we wanted it to be for the whole community. We wanted it to be a valuable tool over a long period of time. And so we opened it up for anyone to contribute to and improve. So we had done that. And so for this project, I felt like the same type of philosophy, and we want this to be have enduring value. And certainly what we learned the past couple months is every week we wanted to produce this, or publish it, there were like four new announcements from developers and Google papers, etc. And we're like, what we'd, if this were just a standalone document, it maybe it's the best go-to shareable document today, but next week it's stale and out of date and people would stop sharing it. So by making it a living document and an open project, hopefully it's always the freshest and most comprehensive, and hopefully it comes to be seen as like the most credible and neutral source of information on the topic, with no hidden agendas about the topic.
Yeah, yeah, I totally agree with that. Yeah, that was a big thing coming in where we wanted to both be informative, but also stay neutral and also do it in a way that's appropriate in terms of how Bitcoin's open source development works and that process works. So I think, one of the things about this report is, or one of the coolest things, one of my favorite parts is the orderly transition scenario. So we're basically saying that there's a likely path and what that looks like. And then we're also very tangible with the mitigations and things that are being worked on, because I think that's a big question for people. And it's not always clear. It's not, always in one place or easy to see. So I think that's another facet there. But now I think we can actually jump into the report itself. And we'll start with our first part, which is the state of cryptographically relevant quantum computers. So I think this is like where we probably have the least comparative advantage, in the sense that none of us are physicists, none of us work in quantum computing, none of us have any sort of insider knowledge there. But it's still something that was important to cover, just to lay a foundation, have some groundwork, and kind of it's the premise of the report in some ways. And it's also something that I think is it's really hotly contested, and it's something that everybody has an opinion on, and it's really hard to satisfy everyone. So I think let's start off by saying, or by talking about how we're choosing to frame this, or frame this sort of idea of cryptographically relevant quantum computers. Like, why is this something that is worth preparing for, but what is kind of the middle path that we're trying to take, as opposed to kind of being dogmatic or getting really far in either extreme.
Yeah, I'll start. I'd say that yeah, none of us are experts, and I don't think anyone in the world knows when there's going to be a cryptographically relevant quantum computer that can economically steal Bitcoin. Um, there's camps anywhere from like it's 2 years away, 10, 50, or never, and there's camps in all those buckets. We're not here, and this project doesn't purport to say it's where it falls in that spectrum. Um, but I think there is enough development to suggest that not it's non-zero risk in the future, and whether that's 2 or 10 or 20 years away, having some level of preparation seems sensible. You can certainly debate to what level, to what degree should there be investment in R&D, in discussion. Like we all have, there's many things to discuss about in Bitcoin. How much out of the proportion of all of our time, how much should it be quantum? We can debate that, but non-zero, I think, is prudent and responsible. And I think we've seen that from uh, cryptographers, from developers, from investors to pundits. There's few people today, I think, saying there should be non-zero attention to it. But and from this project's perspective, we're like, we don't know exactly, and no one else really does know either when it's going to happen. But we'll get to it later in the report, we speak to potential solutions if they're needed in different timeframes. One in which this is maybe 10, 20, 30 years away, and what does it look like over that time period? But also, what if it is more like 5 years away? Or what if the most extreme worst case scenario is like just one day we all wake up and it's occurred? What happens then? So I think the report does a nice job walking through what it could look like. And I'd say it's important to state this is not some kind of like recipe that everyone's agreed to. I mean, we're not going to get to consensus today on what to do in these various outcomes. We're only going to know in the moment. But having thought about it ahead of time, discussed it with many people in the Bitcoin space, get people's gears running in their head, and putting together plausible plans in different scenarios puts us in a much stronger position if and when those occur to do something smart versus dumb in such a situation.
Yeah, I don't have too much to add there. Quantum computing is certainly not my area of expertise, and I try to be intellectually honest and notice when quantum computing does come up. Sometimes I can find myself, it's almost like a recency bias where I'm trying to think back to what is the most recent opinion I heard from someone I respect, and then kind of attach myself to that. So not fully, but it's something that I noticed, and I'm very happy with the way we approached quantum computing here, which is, as Steve was saying, we try to just acknowledge that this is a concern and this is a real thing that we need to think about and prepare for. And if we take that as a given, what happens next? What are the options that we have? How might it play out? Really providing this mental framework to think through those actionable steps that we can take. And I think that's a very important thing because also it's very complex. As we'll talk about, the attack vectors and where things are applicable is very nuanced and specialized, and it depends on other things as well. So I'm happy with the way that we laid it out, and I think that we really leaned into our strong suit here at Presidio Bitcoin, which is focusing on like what are the options Bitcoin has, what is the threat, and how do we think it might play out.
Also thinking through from the technical angle, cryptography, but also um, philosophical angle, because there's some questions that are posed here which there's no objective answer. There's not like we can, there, and this is like what to do with Satoshi's coins. There's not like a formula we can apply to it and get the right answer. It's a philosophical question. So we'll get into that in a bit more detail. I wanted to say one more thing about different audiences, maybe reactions to the quantum question and maybe this report. I think most people are sort of in the middle and they're just like, don't know much about it, heard about it. Is it a problem? Is there a plan? I think that describes most people. But then there's extremes on both ends too. Extreme on one end is this is a complete waste of time talking about this. It's never going to be a problem. It's physically impossible. And like I accept that might be true. It might be true that this will never come about. But because I don't personally know, I can't like confidently say that's true. Um, Again, I think it's responsible to like think through the problems and have a plan. And then the other extreme group is, you know, feels like this is by far and away the most important problem with great urgency, and we need to act. We, the Bitcoin ecosystem, needs to act and fix it immediately. And I think for that, and we can get into some of the details, but there's no solution without drawbacks today. There are many potential solutions. We'll go through cover quite a few on this show, and the report goes into detail. And of course, if we're faced with the reality of a quantum computer stealing Bitcoin, we're going to have to take action and suffer some of these other drawbacks. But we shouldn't willingly want to suffer these drawbacks. It would, in many ways, set Bitcoin back in the Stone Age in terms of functionality, like loss of HD wallets and loss of threshold signatures and these capabilities that all Bitcoin companies rely on. They're not going to be eager to adopt this prematurely.
Yeah, yeah, yeah. So agree with everything you guys say. I guess I've also been thinking more about this just because of some of the conversations that we've had here. I guess like quickly two or three things. I think one is just doing a sort of expected value calculation. So if you say it's a non-zero chance, even a very low chance, but given how potentially destabilizing it would be to the network, to the market value of Bitcoin, I think that it's something that warrants consideration and preparation just from that angle. And then I think the other one is, if you're talking about people getting involved in the space, whether we're here in San Francisco and Silicon Valley, so getting developers to start working on Bitcoin or building on Bitcoin, or capital allocators or whoever it is, the fact that some of the most sophisticated and capable organizations in the history of mankind, so a Google or a Microsoft, and they're saying that these are feasible, that cryptographically relevant quantum computers are feasible. There's this like sort of tangible timeline for them. We're doing a lot of development. Just the fact that they're saying that, is kind of the cat's sort of out of the bag, if you will, in a sense. And not that we should blindly trust them, or and they have their own set of incentives, but I think that that at least warrants some type of thoughtful, measured response, even if that means just
Yeah.
preparation.
I'd like to comment on that. I mean, first of all, I agree with you that's meaningful. But one thing that the audience should not that should not be misconstrued is that when you see things like NIST having a timeline of 2030 or 2035 and Google a 20 moving into a 2029 type of time frame to deal with this, that does not imply that they think there'll be a computer that can steal Bitcoin in 2029, because there's other applications of quantum computers. Another application is that one exists in the year 2060 that can get access to data that was encrypted in 2029 and decrypt it. And that could be very bad for whether it be a Google or the government or any kind of sensitive data that was intended to be encrypted forever. So it's prudent for that use case to do it as soon as possible for things that might occur decades away. It doesn't directly mean that Google thinks so Bitcoin will be stolen in 2029.
Yeah, yeah. And then, yeah, I mean, I guess the final point that I would add, I mean, right now, as you said, yeah, the timeline is just extremely uncertain. I think, you've had progress in error correction and in resource estimates, but a lot of, in terms of actually building the CRQCs themselves, there do seem to be a lot of major hurdles in terms of like the physical constraints. So in terms of like cooling or like how much energy is required, and those are kind of unproven bottlenecks, or in the sense that there's no repeatable scaling trajectory there. So, I think just balancing all of these ideas, but still saying that this is something that we should prepare for and is worth considering, is, I think, the prudent and thoughtful way to go about this, and that's kind of the route that we've taken. Um, so, yeah, I mean, going now, actually getting into what we're qualified to really discuss. I think so, we're talking about cryptographically relevant quantum computers, but how does that actually affect Bitcoin, or what is, what's the impact on Bitcoin there? Um, if either of you want to.
Sure, I can take a stab at this, and then you can jump in, Steve. So within Bitcoin, there's public keys and there's private keys. So public keys are things that you'll often use to say like, hey, I want to receive some Bitcoin. I'm going to take my public key and I'm going to create like an address and you can send me some Bitcoin. And ultimately, to prove ownership, to be able to spend that Bitcoin later, I need to be able to generate a signature and I use a private key to generate that signature. And the signature is just like, what it's supposed to be for any check. I'm signing that I'm authorizing the transfer of these funds. So that's like a specific thing within Bitcoin is authorizing the transfer of funds. And then with quantum computers, that disrupts this dynamic because what is supposed to be public keys are supposed to be public, and that's okay. Private keys are supposed to be private, and then that's how it's designed. With quantum computers, if you have a public key, you're able to derive the private key and then generate a signature, which would allow you to take somebody else's funds. And
Just a
then,
little background too.
yeah, go ahead.
What's today you can take a private key. It's a one-way function to take a private key, generate a public key, but you cannot using a classical computer, at least with known with known algorithms, generate a. You can't do the division of large numbers to generate a private key from a public key.
Yeah. So that is like a specific part of Bitcoin that is impacted. There's to a lesser extent mining, and maybe we'll talk about that later, but not to even like I was listening to a project recently, even Project 11 was saying, don't think about mining. But then so like a lot of other things that people think about when they think of Bitcoin, like 21 million hard cap, that's not impacted. Consensus rules, not impacted. Like it's really this, which is an important part, which is why we're having this conversation. It's this ability to essentially prove ownership and authorize the transfer of funds, which is this area that we're having this conversation about.
And then there's some coins that people hold where their public key is already publicly exposed. I think there's an estimate slash floor of at least 6.5 million that are exposed. And the remaining Bitcoin, the public key is not yet exposed. But it would be exposed when they are attempted to be spent. So that was the report gets into that dynamic and short range versus long range attacks. If you think about a quantum computer, if it takes a lot of time to crack a key, then you're only concerned with long range attacks, which would mean these coins that are already vulnerable, already have their public key exposed. With a short range attack, that would be a quantum computer powerful enough and economical enough that in real time, it could produce a private key from a public key exposed so that when someone goes to spend their Bitcoin, it's a publicly broadcast transaction. And if a quantum computer can intercept that in real time, generate the private key, it can compete with the true owner to spend that Bitcoin.
Yeah, and maybe analogies always run the risk of working for some people and not others, but it's the same technical thing that's being that is happening in both situations. You are deriving the private key from the public key, and you are generating a signature. So it's just like when someone's writing the check to spend, do you sort of intercept the check immediately and then create a new one, or do you have the luxury of being able to like they're not even writing the check, but their account information, and you can do it without them even being in the process of writing that check. I don't know if that analogy goes too far out there, but adding it.
Yeah. I think, I think there is some people question whether or not we should make this distinction between long range and short range attacks, but I do think it's worthwhile, because basically one way of thinking about it is what would be immediately vulnerable if a cryptographically relevant quantum computer existed today versus um, what is more or less safe until spend, right? So at rest, what's safe. So that sort of immediacy and what's immediately vulnerable, I think making that distinction is valuable and worthwhile.
Just to cover the other side though, or like why people would criticize that distinction, is that they would say, well, some believe that once we get to a CRQC, they don't even see a distinction between long and short range. They think it'll immediately be short range capable. That's their view of the technological development of quantum computer. That could absolutely be true, but I think it's really hard for any of us to say that we know that to be true. So I don't find that to be a valuable reason to get rid of this distinction. The other one that is a little more compelling to me is that today there's 6.5 million or so Bitcoin exposed public keys. We know from the report that a majority of those are from large exchanges that do address reuse. So that's solvable. Like that's not too hard for exchanges to solve. And then we could reduce it to, you guys know the numbers better than me, but like 1.7 to 2.5 million coins or something like that that would remain to be exposed. The other argument is, well, even if you get it down to 1.7 million exposed, if there's a out of the blue attack that steals every available Bitcoin, even if 1.7 million are stolen, that would be, I mean, depending on what the thief does with them, but if they dump them on the market, it would be so disruptive that whether it's 1.7 million or 6.5 million doesn't, it's still a very devastating short to medium term impact and maybe long term.
Yeah, I mean, I guess, well, yeah, so that's, I mean, that those are all valid points. I think another one, which we'll, I guess, sort of get into now or in a little bit, is also mitigations. So I think that, while they're not the most palatable, and we'll discuss the trade-offs in them, there are ways to make the spends safer if there is a live CRQC. Um, so I think it's a bit of a, I think that's a bit of a distinction, or that's something that's worth adding as well there, in terms of the impact, because if you if you have your public key exposed, and say you have a CRQC that's live, and it takes your coins, and then after taking 50,000 coins, um, some mitigations are put in place. Well, your coins are already gone, and unless you're assuming that there's some type of chain rollback or something, that's gone for good. Whereas if your keys were behind, or if your public key was behind a hash, then your coins would still be safe, and you wouldn't have to really deal with that or think about that. So, I think the distinction is worth making, but yeah, I think there are both sides. Both sides have some compelling arguments there. So I think, so, we already kind of covered, I guess, now, one of the things that can be done today in terms of custody practices, to sort of mitigate the impact of a cryptographically relevant quantum computer. But I think one of the other interesting discussions there is then, like, why do these, so most of this address reuse number seems to be concentrated among custodians and institutions and exchanges. Um, so, what, I guess, one, why do they do that? And then two, like, why does that kind of make the number less scary, the 6.5 million number? Um, do we want to?
Well, for the first one, I don't know if I have the whole list of why they do it, but certainly, anyone who's used like a Kraken or different exchange before, one feature they offer customers is like to whitelist addresses, so that like if you're transferring from self custody to the exchange, you can set up your self custody wallet, hardware wallet, whatever you have, to only send to um, a specific set of addresses, and by reusing addresses, it just creates a better user experience for that type of use case. So that's one example of, I think, why exchanges wouldn't be eager to stop address reuse, and they might have other reasons as well.
Yeah. And then talking about another, I guess, well, maybe we can cover this. Okay, so actually, so we can jump into some more of the mitigation. So I think the first part, or the first thing that we'll go through, is an orderly transition scenario, which I think is kind of the base case. And this is something that we feel is likely, but it's not necessarily bound to happen. So just to set that caveat in there. But maybe if we want to, maybe if Austin, you want to quickly, or not quickly, but if you take your time, but if you want to sort of go through the steps there, and kind of some of the things that we'll be thinking about, in terms of signatures and output types, and you know doing those together separately, and some of those nuances, and what that looks like, and maybe the migration part too, which I think you had a really powerful and important revelation around.
Well, when it comes to the migration part, that was not my idea. Can't claim full credit for that. But I do think of okay, so with the orderly transition, and let me know if you guys have other helpful mental frameworks here, because I feel like this stuff is genuinely complicated. So part of figuring out what to do is figuring out the right mental framework that resonates with us and with others. But I see this as we have these building blocks that we have access to, and the question is like, how do we put them together? And it's also like in this distributed way where people are going to be contributing their ideas and then they're going to be writing code and we're going to have to, soft work them in. It's just a battle of all these concepts trying to figure out like and they all have trade-offs as we were talking about before. Very real trade-offs that ultimately get to like philosophical differences. So I think one big part of this is obviously coming up with a post quantum cryptography scheme. So, right now we have elliptic curve cryptography. And for the reasons we discussed, that is not going to work for us in a post quantum world. So, there's all these conversations now and research that's being done largely by Blockstream and others into which post quantum cryptography schemes are going to be beneficial specifically for Bitcoin. Because post quantum cryptography schemes is well known that like the signatures are going to be larger. A larger on-chain footprint has a meaningful impact in Bitcoin. The public keys are going to be larger. There's different times that it might take to sign or to verify, and also there's different schemes based on different mathematical assumptions. Some of the mathematical assumptions, specifically like hash-based schemes, are ones that are already baked into Bitcoin. So those are seen as like safer options because we're not relying on new mathematical assumptions, and that makes it so that it's easier, I think, to reason about including that as a cryptographic scheme for Bitcoin, because Bitcoin is very hard to update by design. So the last thing that anybody wants is you would bring in a newer post quantum scheme that is based on newer mathematical assumptions, and then all of a sudden in like 5 or 10 years or whatever, it's like, oops, that didn't quite work. Now all of these freeze conversations that we're having now, you'd kind of be having similar conversations in the future too, because it's like, all right, now we need to move to a different post quantum scheme. What do we do with everyone who has coins locked to the old scheme? And it gets super muddy. So, all that to say, it's very important to think about this deeply and then implement something that we're confident in. And I will throw it over to you in a moment if you want to comment on some of the like nuances when it comes to wallets. But this is all to say, I think right now there is this more convergence on a post quantum cryptography scheme that is hash based, not new mathematical assumptions. And now it's pretty much trying to figure out and doing the research, how do we find ones that are tailored for Bitcoin? So there's going to be a smaller on chain footprint. Um, I don't know, Steve, if you want to speak to more of the like stateful and stateless options that are being discussed, or at least the nuance that brings into hardware wallets, because it does really get super specific. You have these different schemes based on different assumptions, but also different properties of schemes that has a big impact on Bitcoin.
At least at broad strokes. I mean, again, I think if you're new to this topic, you might have the simple question of why doesn't why don't the Bitcoin devs get their act together and just upgrade Bitcoin? Everyone else is upgrading, just upgrade Bitcoin. And it's important to understand that every solution proposed has drawbacks, a different set of drawbacks. So, um, as an example, is what you just brought up, which is the stateful versus stateless types of cryptographic solutions. And so one of the proposals from Blockstream um, introduces a hash-based cryptography, which is quantum resistant. That's good. It also has, I think, the best or a very favorable profile in terms of signature size. It's still something like 6 to 10 times larger than exists. I think it's like around 6 to 8 times larger than existing
That
signatures
is 5x.
or 5x. Yeah. So it's still dramatically larger, but it's an order of magnitude less than many other solutions on the table. That's good. But it introduces stateful design. All that means is in order for you to uh, back up your wallet and recover in case you lose the primary key material or your primary like signing device, you need more than just the private key. You need this additional state. and it's very vulnerable data. Like just like your private key, you don't want to lose track of this data. Um, so it just complicates self custody, or it complicates custody if you're a custodian. There's a variation of that same, and that's I believe it's the shrinks proposal. It's an acronym, and then there's shrimps, which is very similar, except it's a stateless design with larger signatures.
Yeah. So maybe also one thing that's helpful to note, because we're talking about the orderly transition. And I think it's fair to say, as we define that, it's kind of like a quantum computer isn't happening tomorrow. This is like we're taking a reasoned and thoughtful and research driven approach into the post quantum migration. This isn't the like emergent scenario, which we might touch on a little bit more later, but just having that in the background as people listen, um, that's why we're having all of these discussions, is we're really trying to figure out what what is a prudent decision. So there's that conversation, which is all part of this orderly transition. Then there's the conversation of output types. So briefly, we've heard us before talk about some public keys are exposed, some public keys aren't exposed, and that's because they're locked to different output types. They're locked to different scripts or different like you can think of them as like they are their own smart contracts. It's just some of them are having the public keys exposed and others aren't. So with post quantum cryptography, do we put them these new signature schemes? Do we put them within existing outputs? Do we create new outputs for them? And if so, when we create new outputs for them, how are those designed? How do we want to design new outputs such that the existing functionality of current outputs that people put a lot of time and effort into, such as pay to taproot, namely, like how do we keep those benefits while also putting us in a position to prepare for quantum? So some people are proposing like pay to Merkle root now, which is BIP 360. That's saying let's not expose the public key in this output. So you're locking to this the hash of the Merkle root, and then that is getting rid of this exposed public key issue, and you can still implement this post quantum cryptography scheme within this new output, and that would be a full solution. There's other um, trade-offs. It's always trade-offs. There's other proposals that are being championed. One of them, I think it's called P2Q, which is similar in the sense that we're still going to take this post quantum cryptography scheme. We're going to have it be a spending path within the taproot structure, except we're not going to remove um, the key, the key path spend immediately. Instead, we're going to put like a versioning so that it can be more easily removed later. And the idea there is let's preserve some of the other things that we've worked hard for, like Frost and Musig. So being able to take public keys and combine them together and have them be one public key on chain and have this be an efficient private spending path. So it's like, let's preserve that. But then also, in case the quantum computer comes down the line, it's easy and it's defined to make that upgrade. That's another output type that's being proposed. So there's multiple. It's not clear to me exactly which one is going to get the most like championing right now. I mean, BIP 360 seems to certainly be the most popular, but this is part of this orderly transition in my mind. Is there's research into post quantum schemes, and then there's also all of this conversation around, how are we going to pair that? Is it going to go into a new output type? Do we put it into the existing pay to taproot output type? But then that can get a little weird, because then if you're going to, this gets into the freeze conversation. If you nuke or disable the key path spend, then that can get a little bit tricky. But I do think as part of this orderly transition, there will be, I'm imagining, you can let me know if you guys are thinking differently, some convergence around both of these, and they would be included in part of a larger soft fork. And I think both of these together would provide a lot of that, taking us to this new post quantum world.
So I'll try to paint a possible path here. And so let's assume it's like 10 to 20 years before there's a CRQC. And then you can imagine the next couple of years, the kind of discussion and debate going on right now. And then there'll be a soft fork in a couple of years that introduces something like BIP 360 or some ability for people to create a transaction which has a post quantum uh, signature or cryptography. And let's say the same soft fork also contains an actual post quantum cryptography, could be shrinks and shrimps or something else developed over the next few years. Um, then we're talking about 2028, 2029. All in parallel to that work, if it looks like there's momentum there, wallets and exchanges could be working in parallel to upgrade their systems to support this new version of Bitcoin. And then they could offer it to their customers and users in a similar time frame, 2020, 29, 2030. But then it would be voluntary. I mean, it would be, if you're an exchange, it's voluntary whether you upgrade. But if you do upgrade, you're upgrading on behalf of your, hundreds of thousands or millions of customers. If it's self custody wallet for individuals, it's up to them when they upgrade. Because again, with the technology we have today, there are many drawbacks to it. It might be resistant to quantum theft, which is super important if you need it. But there are other drawbacks. So over a long period of time, you'd probably see some people upgrade out of concern, and then a lot more people upgrade if there's more and more credibility around like it's becoming imminent. Like you see a shift from like a few percentage of people thinking it's around the corner to like 20%, 50%, 80% of people. You're going to see more urgency to shift. And again, if we're assuming a time frame of like 10 to 20 years, it's fine if people, if it takes years for people to migrate. In parallel to all this, I would expect the cryptography community to just continue and researchers to continue to improve cryptography. There's been tremendous progress the past 10 to 20 years. We can expect that to accelerate. I mean, for anyone who says like AI and just technological progress around quantum computing is going to accelerate time frame for that, the same logic applies to cryptography and creating better quantum resistant cryptography. So as that improves, I could imagine if there's a huge leap in capabilities, so you don't suffer many of these drawbacks you'd suffer today, could lead to the introduction of another signature cryptography scheme in Bitcoin in 10 years. And then all of a sudden it's like, oh, well, now it's a no brainer. Of course, I want to upgrade to be safer in case of this threat. And plus, I've learned more over the last 10 years that it's now a more credible threat than it was 10 years ago. And I don't have to suffer any drawbacks. So I could see that playing out as well.
Yeah, and I think, just to ground the discussion a bit, I think there's two parts. So one is around actually introducing a new output type, introducing a new signature scheme, introducing them as a package. There has been recent precedent for that. So in 2021, with Taproot, introduced Schnorr signatures and the P2TR output type. So there is recent precedent of doing this, and I think another point is around migration capacity. So I think you know uh, there are some crazy numbers thrown out there that'll take X amount of years to migrate all of Bitcoin, and it's going to be this super slow, cumbersome migration process that's going to take forever because of block capacity or whatever else. And I think we found that 90 if you assume that Bitcoin if you assume 25% of Bitcoin block space being used, you can migrate 98% of Bitcoin's value in 3 weeks, 3.5 weeks. Um, so, that's again just assuming 25% of block space being used. Um, you can, 98% of Bitcoin's value is can migrate over in just 3.5 weeks once you have this optional spend path.
Yeah. So if it's whether it's a scenario where we have plenty of time to migrate, or even another scenario that the report contemplates, which is like it's an imminent threat. Like we have a year or two, or I forget exactly how we framed it, but either of those scenarios, I don't see it a challenge to migrate folks. Like other challenges before us are much bigger problems. The only scenario where it's a challenge is like if it's like literally immediately, like right now, it's being stolen, and we addressed that a little bit too. But that's an extreme scenario where you really have to. I mean, there'll be discussions about reorging the chain at a certain block height. There are things that like no one wants to do in Bitcoin, but you'd be in that situation. So I actually don't really see time to migrate as actually that important in any scenario because I don't see it as being causing issues.
Yeah, the one thing I would just say in the spirit of don't trust, verify, if you want to verify any of this, you can look in, you can see the math that's in the report. Also to speak to some of the other numbers I've seen thrown out. If you ever see numbers, dig into them or ask AI to dig into them. But like one of the reports was that it was estimating that it would take 78 to like 300 plus days for all of Bitcoin to migrate. And I believe if you look into the report, it's assuming all UTXOs migrate. And then if you look at what we were citing in our report, which was Mempool.Space's UTXO report, it's like 49% as of last year. 49% of UTXOs were dust. So it's almost like if you're trying to do an analysis to see how many people are going to open a bank account if it costs $25 to open a bank account, you don't include people that don't have $25 to like in your estimate of how long it takes to open a bank account. So we were taking a different approach. We're very specific. We're talking about value. You can look at the math, but we're trying to show, which we've talked about, you can migrate the vast majority of Bitcoin's value in a very short amount of time. So if you do see numbers that look scary, just double check them.
Yeah. Well, so speaking of the rapid response scenario, that is also something we covered, and that's where we already sort of have these different permutations within the orderly transition scenario of signature schemes and output types, and there are a few different paths here, but this is where the paths or that sort of space kind of explodes in all these different potential scenarios you can have for rapid response. But I think one of the resources we really leaned on in this was something that Chaincode Labs has put out with in conjunction with Bitcoin developers on what they think is uh, a sort of timeline for a rapid response, given that CRQCs kind of suddenly seem imminent without having had time for this orderly transition and this migration. Um, so I think that one well, so I think that there are a few places we can start with this. I think one of the things uh, is there even precedence for Bitcoin moving this quickly, right? Like in a matter of, days or weeks or even months. Like, is that something that Bitcoin can actually even do?
And I mean, so the answer is yes, in the sense of a consensus change and getting the network upgraded. There's several instances in history that show that it can be done. The most recent being 2018, there was the inflation bug that was responsibly disclosed by a developer. And within in under 24 hours, a small set of core developers evaluated it, confirmed it was a severe bug, identified the fix, which was complicated, created the fix, tested it, contacted large mining pools, and got it upgraded. And I forget the exact time frame, but I mean it was like within 1 to 2 days, and then disclosed it once majority hash power was supporting it. So that's a concrete example. Now, for this, it's a little more complicated, and that it's not just so could Bitcoin take like Bit 360 and Shrinks and Shrimps proposals for cryptography and um, upgrade the Bitcoin network quickly? That's I think yes, um, but all the wallets would need to upgrade too. And then users would need to perform transactions to migrate, like we were just talking about migration timeframes. And while I think all of us, if you look at the numbers, we're bullish on like pretty short timeframes to migrate a lot, majority of the value. It's still not like within a day. So in terms of rapid response, if we're talking about like, oh, okay, now there's clear evidence it's going to happen in the next couple of years. Um, I think there's enough evidence and development in the pipeline that we absolutely could respond in time. If it's on the order of like a week, then we're in trouble. Then we're in the most serious emergency mode of, we'd have to have just tough conversations about at this block height, that's the last valid Bitcoin until we get our shit in order for everything else in Bitcoin and then resume. Um, we have to prepare for that possibility, but hopefully it's not that extreme of scenario.
Yeah. So, well, yeah, I guess so we can come back to this discussion about freezing and free yeah, about this whole sort of freeze discussion because it has taken a life of its own over actually the past few days with the recent BIP. But I think if we want to just touch on one more thing, which I think you have some opinions about, so in this scenario where there's live CRQC theft, right? There's a cryptographically relevant quantum computer that's capable of a short range attack, meaning you can't even spend safely in that 10-minute window. It can um, take your private key. There are some solutions there. So the commit reveal scheme, or I think Taj calls it Lifeboat, as well as private mempools like Mara Slipstream. So I don't know if it was. I think one of you felt strongly that that's sort of like, that basically shouldn't be used, or that's like an absolute last resort and should only be used in this emergency scenario. Maybe you can touch on
I,
why.
yeah, I had that view, but I mean, let me qualify it by saying I learned of Taj's lifeboat proposal at the Quantum Summit. I think it's typical Taj. It's like really smart and insightful and novel and good to have as part of the discussion. Um, but my assessment of it at the time, my concern with the drawback is that it felt very centralizing because you need some centralizing body to facilitate the transactions. Um, that's where I say maybe I'm wrong or maybe it's evolved since then. But to the degree that it's true that you need centralized actors to facilitate the commit reveal, and I believe the proposal forced all Bitcoin users to use this. It wasn't like a voluntary opt-in thing. Everyone has to switch. That's why it felt like that's not. It doesn't. If that's true, it should not be what we desire to be a solution. It would only be in like this emergency situation where there's a lot you're facing very difficult challenges ahead.
Yeah, but I mean, in that situation, it is a powerful mitigation
Yeah.
because it
Yeah, I
kind of
agree.
removes the life
If
risk.
we're in this very dire situation of like the attacks happening right now, then it becomes a lot more compelling.
Yeah, and maybe we can stress test each other here too, but I think you could probably, because part of it is you have to get the hash. You essentially create the spending transaction that you want to send, which is going to be vulnerable because it's not yet in the post quantum scheme, using a post quantum scheme. And then you take the hash of it. So you get this identifier for this transaction you want to publish later. And you just have to get the identifier on chain. So one way would be through a private mempool. Also, I mean, I think you would have less risk here, but if you just have a UTXO that's like very little amount and you just like you create your own transaction just to get that put in like an op return, the identifier, I think you would minimize your risk, maybe minimize some of the centralization. But so that's a good thing if that's true. But I guess if everyone has to also be verifying this, I don't know if there's a way where it's like if there isn't a commitment for this transaction, we let it go. If there is, or if there's multiple, it's only the first. So if it's not, everyone's forced into it. Because if everyone's forced into it, you're forcing two transactions to essentially do one transaction, which isn't ideal. However, as we're talking about, you're at this point, we would be choosing the least ideal among many non-ideal, or the most least ideal. I don't know exactly how to phrase that, but like some of the other things we've talked about, one recently came out last week was one way of like locking your funds in such a way that to spend them requires, what was it, like $75 to $200 of GPU costs. Again, not ideal, but if we're in this sort of emergency scenario, then I think people are going to be wanting to figure out like whatever works.
But the nice thing about that particular proposal, or the highlight of it, is that it doesn't require consensus changes.
Yeah.
So, and I believe, I think Ben Carmen, his mempool inspector, I forget what it's called, but it detected an anomaly, which was it actually detected one of these transactions. I didn't look into it to know if like we know with certainty or if it's just an estimate, but possibly someone already did one of these where you do it's without a consensus change. You can do a hash based authentication to spend, and it does require you to grind matching like a hash pre-image to your pub key. Um, but that's the huge benefit with that approach. It doesn't require consensus. If you have coin, if you're super worried today about quantum computers stealing your Bitcoin, you can act today and use this. Now, are there drawbacks? With everything, there's drawbacks. So one, it's I don't even know the state of the code, so it might be like alpha level code, might have bugs. Um, the I don't believe it's using any novel cryptography. So I think beyond, as long as the implementation is sound, I think it should be a sound design. Um, then there's the cost of the GPU grinding. But again, if your UTXO is worth $200, first of all, I wouldn't be stressed about any of this stuff. And secondly, you shouldn't spend $200 to protect $200. But if you have $200,000, then who cares about $200? Then the other drawback to it was that it produces a non-standard transaction. So it would not be relayed on the Bitcoin network. You would need to submit it directly to a mining pool or a service like Slipstream. So again, if you have a $200,000 or millions of dollars UTXO, it's worth your bother to like arrange that deal and get it done. But as a broad solution for everyone and works for everyone's wallets, it's not as good as other proposed solutions that would require a consensus change.
But yeah, so I guess in this emergency sort of live theft scenario, this is also pretty powerful for migration.
Yeah.
Safe migration. Yeah. So I think now we can finally, and we're sort of rounding the curve here and getting to the end, but now we can get into
the thorniest problem.
Yeah,
spicy stuff.
Now we can get ourselves in real trouble if we haven't already. So we've mentioned it a few times. We've been talking about freezing. I think that I think one of the things is what the community, what Bitcoin decides to do with legacy coins. I think it depends on a lot of different things. It depends on the ability to recover those coins and how confiscatory it is. It depends on the path, right? So, are CRQC something that just come out of nowhere, or is there this sort of long leeway and transition scenario, or long leeway in transition where you have 10, 15 years to prepare? I think all of that sort of changes the calculus around this. But I know Steve has really enjoyed the game theory and discussing this. So maybe if you want to break down sort of how you're thinking about this freeze versus what they call, I guess, steal approach, or how you think that might play out.
Bitcoin principled approach, I think advocates of that camp would say.
I mean, yeah,
but yeah, I mean, what to be clear here, whether it's a 20-year orderly transition or an emergency rapid response, whatever the timeframes are, this issue exists. And also, let's say we develop over time the perfect post-quantum cryptography, no drawbacks, and it's quantum resistant, and we get community buy-in, consensus, we upgrade Bitcoin, everyone upgrades their Bitcoin to this, we still have this problem. And we have this problem because it's not proven, but it's highly likely that there is a substantial amount of Bitcoin that will never move. It'll never be spent. And
I think the exact number on the main tranche is about 1.72 million. So just to put out of the 21 million total.
And these are mostly pay to pub key coins, and it's a technical term, but it just simply number one, the public key is exposed. Number two, though, they were mined very early and they've never moved. So we don't, and then about 1 million of them are believed to be Satoshi's coins. There were some patterns that were able to be analyzed, and there's pretty strong evidence that 1 million of those or thereabouts are Satoshi's coins. We don't know whether they'll move or not, but it's been 18 plus years and they've never moved. So that could be due to death. It could be due to lost keys. It could be philosophical, like especially with Satoshi. Maybe Satoshi is alive and has the private keys, but just won't spend them for reasons known to him or her. But in any case, I think most people agree they're unlikely to move. And if they don't move, it doesn't matter if we have the perfect solution. they're the only ones that can spend it. And if they don't, then they're going to be vulnerable, which then presents the philosophical question what to do. So one camp is don't do anything. Let a quantum computer steal the coins. That's the most principled take as a Bitcoiner. How is it up to any other group of people, including the rest, all of Bitcoin, except for the rightful owners of those coins? Why is it up to them to decide to take these coins from those people? It's like violates a basic property of Bitcoin. I think everyone agrees with that stance in general. It's a super important property to Bitcoin. In this specific case, though, the another camp is we need to freeze these coins. And why? What's their rationale? Are they, um, you know, do they want to destroy Bitcoin? No. I mean, their rationale is, well, you're facing, it's the better option of two bad options. You're facing a violation either way. Either way, the coins are going to be stolen from the rightful owner, which violates the basic principle of Bitcoin. There's also a concern that what it would do to short, medium, maybe long-term credibility of Bitcoin. If 1.7 million coins are stolen and they're like immediately dumped in the market, it would crash the price. Maybe that's only a short to medium term issue. Maybe it takes 5 to 10 years to recover economically from that and get Bitcoin back to where it was. Um, but maybe it's a death blow. Maybe it's a death blow to the credibility of Bitcoin and it never recovers. Now, the first camp, of course, would argue that like it, if there's a consensus change by others to steal other people's coins, like Bitcoin has lost that action loses credibility of Bitcoin, and thus the value of it is much less than they thought. And maybe there's not an immediate price drop, but over time it erodes the value of Bitcoin. So that's the two camps. Now, there's variations of these. Who possesses the quantum computer and who steals the Bitcoin? So first of all, there's a scenario where someone possesses a quantum computer and they don't steal the Bitcoin. It's not their prerogative, it's not their objective, and whether that's a government that has it, like the NSA or Google or a startup, or they might have applications of like accelerating AI or solving other problems, and they don't want to be criminals, right? This would likely be criminal behavior by whoever does who would steal the Bitcoin. So they don't want to be criminals. So there's an outcome where there's quantum computers, they don't steal. There's others where they steal, but it's like a white hat hacker. They steal and they just burn them themselves. That's kind of a cool, if we could like wave a magic wand and that's the outcome, that's great. Because then the burn occurs. So both camps are happy then, right? Yeah. We didn't change the consensus rules to steal people's coins. The people who have the theft machine burn them for us, and the markets don't crash. But we can't guarantee that outcome. And then of course there's outcomes where an entity steals the coins and they want Bitcoin to die. So they just play games over time with markets. Or there's like a hedge fund or whatever, they want to profit, so they'll play games to like with the price. And it's not, playing a game with the price is not necessarily just dumping all the coins immediately. That's probably not profit maximization for the thief. It's more just playing games over a long period of time. And when you have that large a stack, you can profit handsomely. So I think the freeze camp is like, that would be the most destabilizing. If we don't freeze, it would be the most destabilizing. It would ruin Bitcoin. So we need to take this action.
Yeah, and I think one of the other framings that for the freeze camp that's been interesting, or I guess somewhat compelling, if you will, has just been that this is sort of this is different than a wrench attack and rolling back the chain for a wrench attack or something like that, right? Where this is an in-system problem. This is like a cryptographic guarantee that Bitcoin had that's broken. So that sort of warrants Bitcoin doing something at a system level. I think another thing that we can discuss, because this is, I think, kind of interesting or kind of cool, is BitMEX had put out some stuff, and then Lalu recently put out something as well on different ways to make this freeze less confiscatory. So if we want to talk a little bit about that.
Sure. You want me to jump on it, or do you want to?
Sure. I could mention, I was actually just going to say that because like all things, everything's complicated and, it's not as clean as people might want it to be. But There are methods that are being proposed where you can take your seed phrase, anyone who's, held Bitcoin, I think since 2014 they were introduced, or maybe that was the HD wallets. But if you have a seed phrase, which is just like the 12 or 24 words that you get a lot of anxiety about memorizing or putting somewhere safe, if you have that, people are coming up with proposals where you can essentially prove, like you generate zero knowledge proofs to show that you actually have this information without actually giving it up. And you can use that to claim your funds if they are frozen. So that makes, to some, it more palatable. These two different camps where it's like, okay, if we do freeze certain coins, maybe we remove the key path spend so that these public key, you can't spend with the key, the exposed public key, and also with the pay to public key output types, we freeze these. But if you have the seed phrase, you could reclaim your funds on the other side of this freeze.
One more detail that's important to understand that um, the reason that that would allow the rightful owner to make a claim and a quantum computer cannot is because the quantum computer cannot calculate the seed phrase from the private key. So quantum computer can go from a public key to a private key, cannot go from the private key to the seed phrase because it's a one-way direction from seed phrase to private key using hashing, and quantum computers don't break the hashing algorithm. The other comment I'd have on that, just thinking it out loud, I don't know if we address it in the report, but maybe we should. I don't believe that solution. I think that's a very clever solution, but it doesn't apply to the PDPK keys because they all predated seed phrases.
That's correct.
So that remains a problem. So this seems like it seems valuable if there were an immediate threat that steals modern wallet coins that weren't migrated yet. So in like an orderly transition, we make this assumption there's plenty of time for everyone to upgrade, and then, but there still could be laggards behind. Yeah. So anyway, I think it's a fascinating solution and in the right scenario, it could absolutely be applied. But it does assume the freeze camp. So it assumes the freeze camp would win in such a situation.
Yeah, and one other thing I'd add, and this is from conversations with people here at Presidio Bitcoin, is Bitcoin's a unique sort of political thing where if this is very contentious, which it clearly seems like it will be, and there is a fork, you as a holder of Bitcoin get to not pick a side. You can if you philosophically want to and sell the coins on whatever side of the fork you don't want to support, but you could just watch both things play out. And I've heard people compare this to elections where, yeah, like in elections, one person wins and then that's the person who governs. With Bitcoin, there can be multiple like simulations running at once and you're a part of them all. And then you can decide at whatever point, if at all, to sell the coins, or you get to take a part in each of these forks. That doesn't diminish, though, the fact that the forks do cause real, to some extent, destabilizations in just the environment.
This is my own opinion, but I do think if we get to a point where CRQC is imminent or exists, and we're at the point where these two camps of freeze versus don't freeze butt heads, there will be a fork. Because I think it's philosophy. You can't objectively. There's no rational argument that gets you into one camp or the other, and like definitively. And so I think we'll never see a convergence of the two camps. There's good reasoning on both sides, I think. So because of that, there'll be a fork, and then the market's going to decide. And we briefly mentioned the other project that I was involved with, BCAP, and it speaks to this specific situation when there is a contentious fork, and it analyzes some of the dynamics there. One key point there is that investors rule in such a situation. Like where the chips are placed is a huge factor in what is the world thinks is Bitcoin. So if you have fork A and fork B, and we saw this with Bitcoin Cash and Bitcoin in 2017, the money went towards original Bitcoin, and well, today that's what the world considers Bitcoin. The same would play out here, and And so it it and getting to the point of yes, a unique property of blockchain systems like this is that you can place your bets on both forks. It's the marginal better that decides. Like, if you have, let's say you have three equal investors, they each have the same amount of Bitcoin. If two of them sort of sit it out and they're like, I don't feel strongly about this, or I don't know which is going to win, I'm just going to keep both. That's a sensible decision. But if the third investor is like, well, there's can be two psychologies. One is I'm confident fork A is going to win, whether I like it or not. Like, sort of the trader in this person is like, A is going to win, so I'm going to double down. And they sell all their B coins and double down on their A coins. Another psychology is like, I want A to win. Like, it is the right direction for Bitcoin, and then you can vote with your wallet. You sell B and buy A. But if you're wrong, you might have, instead of doubling your stack, you might have lost your entire stack. So that's a dangerous game, but that is where a fork would be decided, or like where a victor would be decided in a forking situation.
Yeah, I think just adding one more thing to the freeze conversation. There are still, so not all wallets are derived from seed phrases, but there are other methods of making a freeze less confiscatory. So I think for the P2PK coins, I think there's this idea of posting like a pre-Q day hash commitment. So of course, again, it's still um, is you could still make the argument on the other side, of course, that it is confiscatory because after that Q-day freeze, you can't recover your coins. But if you set up this mechanism and give holders, or give the P2PK holders, 10 years to put this commitment on chain and they don't do it, then a freeze seems less confiscatory than it would have otherwise. And that's what, I think there are just so many of these dimensions here where depending on how a CRQC emerges, if it emerges, how it emerges, and who the CRQC belongs to and how they use it, and all of that, I think will definitely change the calculation in terms of which fork seems more compelling or more in line with Bitcoin's values.
Yeah,
Um,
I agree with that. I mean, none of these are going to definitively, again, like get everyone to go from one camp to the other, but it could shift some people from one camp to the other, which might be the marginal difference that makes one fork win over the other. And then another really important dimension to this problem is when or what would trigger freezing of coins. So, and already, like, BIP 361 was just published, or I think, given an official BIP number. Anyway, it's receiving discussion this week and a lot of pushback. Um, and I saw some drama on social media today about, there's a panel up next where apparently people on the panel were talking about, we need to take action now, and we're going to take action now, is from like larger institutions. So anything that's freezing Bitcoins today or soon, to me, seems completely ridiculous and outlandish, and there should be significant resistance against that, um, because there is no evidence of imminent um, threat to Bitcoin. Um, so any kind of freezing, I think, to me, this is my opinion, but even setting like a block height of 10 years from now today to freeze coins seems premature to me, right? So just another dimension of this discussion of freezing is like, when would we make a change to Bitcoin that introduces the notion of freezing, and then how long a window is that? And
Mhm.
to me, it seems it gets more compelling, and you'd win over more investors and Bitcoin users if it's in a more dire situation versus this very preemptive situation.
Yeah, and maybe just to add an example there, something I was reading recently was the idea of having, they call it like a canary. So, and I think the way this was actually proposed was, there's this pot where you can send your Bitcoin in a one of two multi-sig where you can still control one of the keys. You can remove it anywhere, anytime you want, but the other is going to be like the I think they're going to generate with like a nums point. Just generate a pot where nobody knows the private key, and then if a quantum attacker was able to derive the private key, since everything in there is a one of two multisig, they can just sweep all of the funds, and then that would be a signal that now is the time to initiate the freeze or initiate the starting point of the freeze migration timeline. I think that's just an example of some
And
alternatives.
BitMEX just published a variation of that where you'd actually the proposal here would be the code would change so that the freezing would occur if a honeypot were stolen from. So it's not just a signal that we can all look at and be like, oh, I've changed my mind. This would be the software would be coded such that if this honeypot is stolen from, then we activate freezing coins.
Yeah.
So it's way more. It's enforcing that. So it's way more draconian. But again, it's a novel, interesting proposal.
I think that's actually what I was reading.
Oh,
But
okay.
you could imagine a combination of what we said. Like
Yeah,
these
you
are
could
all
have
things.
you just
Yeah.
have one that's just like
Yeah.
it doesn't actually enforce stuff, but it's informative to everyone. Of course, the gotcha there is again, it's a function of like who's stealing and what's their motivation. Because if you're like, if you're the entity that wants to destroy Bitcoin or you want to like profit handsomely, why would you trigger this this honeypot? Like you'd intentionally avoid it. And then if you're I guess but if you are if if like the NSA secretly possessed such a computer, and let's say the United States government actually wanted, I mean, like there's, everyone's pension funds are dependent on Bitcoin. You don't want Bitcoin to die. This would be a way to signal to the world there's very credible evidence that it's imminent. So get your act in gear. So there, I think there are plausible paths where there's sort of this benevolent actor with a quantum computer that could do that.
Yeah, I
It
mean,
almost seems like a no-brainer because I'm thinking about this out loud, but it seems like a no-brainer to have that. Maybe not tie it to enforcing it on chain, but at least have that. I mean, any of us could do it. Any of us could post a little bit of Bitcoin. And it doesn't even have to be a lot of money because in the scenario, because again, it's not someone trying to steal it, it's someone trying to signal to the world secretly that there is a quantum computer. So any one of us should do that.
Yeah.
yeah, I mean,
That's your action
originally,
item, Austin.
It also reminds me of, though, I think I remember hearing a story where Craig Wright was trying to buy early Bitcoin keys to make it look like he was a rat, like he was Satoshi. So you also have to be mindful there could be an opposite where someone claims that like, here's this honeypot, and then
but you can produce it just
yeah.
a single key that no one can spend. Like
Yeah.
you can burn your own coins, and the only way it could be spent is if a quantum computer could spend it.
Yeah.
yeah, I mean, originally this canary concept was in the paper. I don't know if you guys remember that, but it was shot down because the game theory wasn't tight enough around it, which is, I think, still kind of.
All right. Well, there you go. I just gave. I'll open a PR against the project.
well. I mean, and it is fair, right? Because you don't know who the actor is going to be. I would say one other point of nuance here is those P2PK coins. I believe they're spread across 36,000 wallets. So it's not like this person is just, or this actor would just go and like take this giant honeypot. It's like over time, they would have to crack all of these wallets, and in terms of block capacity and how much time it takes to crack the wallets, and all of that, all of the sort of nuance there. And we also saw a lot of these sort of ancient whales spending these P2PK coins as recently as like the last year, right? I think there was a lot of news of these coins being spent in what seemed like a legitimate way. So the actually that was sort of my last topic before closing this out was kind of what would be our signals that a CRQC is more imminent, or like what are some benchmarks that we're setting that like this discussion needs to kind of switch gears. So I guess we've kind of covered that here, but I don't know if there's anything else you guys want to add to that.
We can at least at a high level describe it. Again, none of us are quantum computing experts, but we've certainly read reports and papers and things that are creating anxiety with people. I mean, there's a number of dimensions to follow technological progress. One is around error correction for quantum computers. Another is like the algorithms themselves. How powerful are they, and are there new ones introduced? Like the recent Google paper it gives it like a 20x optimization on a hypothetical quantum computer. That's another track to monitor. And in both those categories, Google and others have had pretty significant events the past year and a half that they've announced. Um, a third track, of course, I mean, it's the most important one, is actually having a physical quantum computer that can scale appropriately. Even with the latest algorithms, it still needs to scale much, much, much more than what has been demonstrated to date. So, with my layman's view of all this stuff, that seems to be the bottleneck. It seems to be the has the least progress, and is the primary reason why quantum skeptics or people who think it's still decades or more away, it's that category. So any kind of big break, especially in the hardware, um, would I think wake up a lot more people in Bitcoin.
And the reason why I think we have to be like a bit more high level about this is because there are also different types of architectures for quantum computers. So each of them have their own physical constraints. But um, seeing one of them basically be able to scale those constraints. So as they improve on the dimension, whatever that constraint is, their error rates go down and their qubit counts go up. Seeing that in a scalable way that's repeatable, I think is something that we'd be looking
We
for.
also haven't touched on, and I think we should state it. It's just because someone's a quantum computing expert doesn't mean you should just believe what they say without any kind of rigor. Because often they are at a quantum computing startup and they have a vested interest. They
Even if they're
obviously
a researcher for
they
their funding
obviously
or
want to
something else,
send the
it's
message to their investors and to the market like it's real and it's happening soon because I started this startup that's expected to produce value not in 50 years, but like tomorrow. Even researchers at universities, they receive funding. So they are incentivized to make it seem relevant in near term. I'm not discrediting all of those folks. I mean, you can apply the same thing to people with Bitcoin. Like if you hold Bitcoin, you don't want it to lose value. So you're going to be biased towards that. Interestingly, with Bitcoiners, though, you can fall into all these different camps. You could be like, yeah, I own Bitcoin. I want it to be valuable. So we need to do something about quantum because we want it to remain valuable. Or you can fall into the camp of like, I own Bitcoin. I don't want to see the price depressed. So quantum's not a problem at all. It's FUD. Dismiss it. So just bear in mind, I don't think any single person has all the answers. This report certainly does not have all the answers. It's imperfect. And again, that's why it's an open project. We want it to improve. So lots of people beyond us can improve this project.
yeah. I mean, I think that's a good note to start to close it off on. I don't know if you have any kind of closing remarks or thoughts.
I was just going to say, if you enjoyed the conversation and want to contribute, go find the GitHub. There's already a few pull requests, which is exciting because the report's only been out for a few days. So people are quite obviously engaged in the quantum discussion. So please get in there and submit some pull requests and just join the conversation.
Yeah, I believe the name of our GitHub is Presidio BTC, and it's the only project there. So it should be pretty easy to find. I don't know if did we not cover anything that either of you were interested in covering, or any angles, or anything, any takeaways that you might have.
I thought this was good. Yeah.
Yeah, no, this was great.